Morning, children. Let's have a deduction of Coulomb's law from Gauss theorem. Deduction of Coulomb's law from Gauss theorem. Right? For this, what we need is to deduct the Coulomb's law from Gauss theorem. See what is given in our Gauss theorem. What is given in our Gauss theorem? Like if there is a point charge q located at the center of the origin and you are taking one portion here, say a ds portion, uh, ds portion in vector form I am writing, and the electric field which will be acting here, the electric field which will be acting here, E vector, right? So E dot ds, E, we are writing E dot ds integration over the closed surface. As per Gauss law, E dot ds integration over the closed surface. This is your delta phi E. This is your delta phi E. Yeah. So E dot ds integration over the closed surface is your delta phi E, and this can be written as E ds cos of angle theta. So cos of angle theta. As you see, ds and the E are acting in the same direction. We can write very well here 0 degree, right? So E dot ds integration over the closed surface is d phi E, which is equal to E ds cos 0 degree, right? And this is nothing but E ds. Yeah, is it right? So net flux through the closed surface S. If this is a closed surface S, the net flux, we need to find the net flux, right? And the net flux will be the integration of E dot ds, the integration of E dot ds over the whole surface. So E dot ds, E dot ds integration over the whole surface, the closed surface S, would be written like this: E ds integration over the closed surface of S, because E ds you are getting here as cos 0 is 1. Okay, so E ds, or as E is constant over this sphere, constant over this because the distance is equal, right? So E can be kept outside, E can be kept outside, and we can integrate the ds element for the whole closed surface S, right? And this can be now E kept outside into total surface area of S, because ds is going to be integrated for the closed surface. So total surface area of S into total surface area of S, right? So this can be written very well as E into total surface area of this imaginary sphere, total surface area of this imaginary sphere is nothing but 4 pi r square. If r is your radius of this sphere, then E into 4 pi r square. So E into 4 pi r square is the net flux, right? Now using Gauss theorem, using Gauss theorem, what we can write is the total flux should be using Gauss theorem, the total flux should be phi E, and that should be the charge enclosed over the epsilon naught. Charge enclosed over the epsilon naught. That means we can write E into 4 pi r square, E into 4 pi r square as q upon epsilon naught. Am I right? So E into 4 pi r square is q upon epsilon naught, or E, the electric field, the magnitude of the electric field is nothing but, this 4 pi r square can be transported to this side. So q upon epsilon naught into 1 upon 4 pi r square. That means the force on the point charge q0, this implies the force on the point charge q0, if force applied on the point charge q0 would be equal to q0 into E, as E is now q upon 4 pi epsilon naught r square. So we can write q0 into q upon epsilon naught into 1 upon 4 pi r square. This means q0 into q0 into q upon 4 pi epsilon naught r square. That means this is your k times of q1 q2 upon r square. Am I right? So this is what the force acting on two charges q0 and q0 is suppose kept here, then q0 into q, k times of q0 into q upon r square. This means the Coulomb's law, the derivation of Coulomb's law can be possible from the Gauss theorem, right? And this is one of the frequently asked question in the board examination. Right? Deduction of Coulomb's law from Gauss theorem, right? So I hope you got it clearly. If Q is at the center of this imaginary sphere, then E dot ds integration over the closed surface should be d phi E integration, right? Integration over the closed surface. So this d phi E is E ds cos 0 degree as E ds. So net flux will be the integration of this, and you will be getting E into total surface area. So E into 4 pi r square. So using Gauss theorem, phi E, the electric flux is q upon epsilon naught. So using it, you can easily derive the Coulomb's law from the Gauss theorem, right? So good day. Next discussion should be related to our class 12th electrostatics. Class 12th electrostatics. Whenever befitting interactions will be happening through our students, then we'll be utilizing this one. This platform can be utilized, and this is how we can deduce. So this is one note. You can take it as the screenshot and make your note perfect for the upcoming board examinations. Okay, thank you. Good day.